All right, here we go with part 2 of 7.1. And we're starting off with cube roots here. So go ahead and continue taking notes for 7.1. So we already talked about the square root. So now we're going to look at the cube root. So similarly, the number b is a cube root of a if b cubed equals a. Okay. And for the notation, we are going to be using this, but it has a little 3 right up in there. Okay. So that means the cube root of a. And it's equal to b if when you cube that b, you get the inside. Okay. And here, when it comes to variables, right, unlike the square root where you have to use the absolute value symbols, with cube roots or odd roots in general, you don't have to worry about that. Okay? It's just going to be whatever that x is. All right, so let's go ahead and evaluate these. Okay, let's take a look at this one. Cube root of 125. So what number do we raise to the third power to get 125? Hopefully you said 5, because 5 to the third power is 125. 5 times 5 times 5. Okay. What about this one? Cube root of negative 1 over 64. Okay, so here we can take cube roots of a negative number, and we still get a real result, not an imaginary one, unlike for square roots. So here our result will be a negative number. And just like with square roots, what's the cube root of 1? 1. And then what's the cube root of 64? 4. Not 8. 8 squared is 64. We're looking for something cubed to make 64, and that would be 4, because 4 times 4 times 4 is 64. Okay, this is 4 to the third power. So cube roots, we're looking for something to the third power. Okay, all right, let's try this one. Cube root of 27x cubed. So again, when you're dealing with odd roots, cube roots, fifth roots, you don't have to worry about the absolute value. Okay, so cube root of 27 would be 3, and we get x. Okay, we don't have to do absolute value. Okay, and again, because 3 times 3 times 3, which is 3 to the third, that equals 27. Okay, let's try this one. Cube root of negative 8. Let's do a to the 9th and b to the 6th. Okay, so let's start with the cube root of negative 8. So the cube root of negative 8 is negative 2. Okay, and over here, maybe it'll help if you write these out, negative 8, and let's figure out something cubed here and something here cubed as well. So 3 times 3 and 3 times 2 will give us 6, right? So it's a cubed that's being cubed, and it's b squared that's being cubed. So this would be our final answer. Okay, so if you need to do this so that you can see what's being cubed, you can do that. Okay. All right, let's take a look at graphing. Graphing cube root. Okay, so let's take a look at the parent function. So we're going to look at f of x equals just the cube root of x. And then again, once we look at the parent function, then we'll take a look at what happens when you have something like this. Okay. And again, you just do the shifting. Okay. All right, so let's do our parent function. I'm going to go ahead and make a table of values so that you know where these points come from. Okay. All right, I'm going to choose 0. So when I plug 0 in here for x, cube root of 0 is 0. Then I'll choose 1. So when I plug 1 in here, the cube root of 1 is 1. And here, since we're allowed to take the cube root of negative numbers, I'm going to go ahead and choose negative 1. Okay, so the cube root here of negative 1 is going to be negative 1. Okay, so I have these 3 points. These 3 points will be my main points for my parent function and when I do any sort of shifting. Okay, so here's x, f of x. All right, so I have a point at 0, 0. I have a point at 1, 1. And I also have a point at negative 1, negative 1. Okay, so it might look like it's going to be a line, but if you remember the graph of x cubed, if you remember the graph for this, it was like that, right? So very similar to this, except it's going to be sideways. So here, it's going to go like that. Okay, so that's our parent function for the cube root function. Okay, all right, so now let's go ahead and take a look at this one. Let's go ahead and graph with some shifting. Let's do g of x, which equals the cube root of x plus 1 minus 2. Okay. All right, so we know that this one here, we'll shift it 1 unit to the left. And we know this here, we'll shift it 2 units down. Okay. One, two, three, 4. 1, 2, 3, 4. Okay, so let's go ahead and place our parent function points. We had a point here at 0, 0, 1, 1, and negative 1, negative 1. Okay, so this is the original function, the parent function. Okay, and now I'm going to shift it 1 to the left and 2 down. And I'll do it in black. 1 to the left. So I'm going to take each of these points and shift them 1 to the left and 2 down. So this will go 1 to the left and 2 down. This second point here will go 1 to the left and 2 down. And this point over here will go 1 to the left and 2 down. Okay, so now my graph looks like this. So very similar to square roots, except we have a different curve. But everything about shifting still remains. Okay, let's talk about nth roots. Again, make sure you just text me or email me if you have questions. All right, nth roots. Okay, so we looked at square roots, we looked at cube roots, so let's just talk about nth roots in general. So if you're taking the nth root of some number, it will equal b if, when you raise b to that nth power, it will equal a, which is the number on the inside. Okay. Here's a little note. If n is even, so like if you're taking the square root or fourth root or sixth root, so if n is even, then whatever you're taking the nth root of has to be positive. Okay, so that's what this little note is saying. So if you're taking the square root or fourth root or sixth root of something, then that something, that a, that something has to be positive or zero. Okay, or else we end up with imaginary results. Okay, let's go ahead and evaluate. All right, so first of all, if x is a real number, if x is a real number and n is greater than 1, then if n is odd, when you're taking that n, that odd root of x to the n, then you don't have to worry about absolute value. Okay, so when you're dealing with like cube root, fifth root, okay, odd roots, you don't have to worry about absolute value symbols. Okay, but if n is even, then you do. Okay, so if you're taking the even root, then you do have to use absolute value. Okay, so that's what this is saying. If you're doing the odd root, you don't have to worry about absolute value. If you're taking even root, like square root, fourth root, sixth root, you have to use the absolute value. Okay, unless of course your result ends up with something to an even power, which makes it positive anyway, then you don't have to, you can ignore it. Okay, so let's take a look. So if I have this odd, right, seventh root of x to the seventh, since it's odd, I don't have to worry about absolute value symbols. But if I have this even, right, then I do have to use my absolute value. Okay. Here you can ignore. You can ignore absolute value if your result is like x2, if you end up with like x squared or x4 or x6 or x8, etc. Okay, because then it's automatically going to make it positive. And that's what we're trying to do. We're trying to ensure that we end up with the positive result. Okay, and having these even exponents makes it positive. Okay, so you can ignore the absolute value in that in those cases. Okay, and this is if your answer is already x squared. Okay. All right, let's go ahead and evaluate these. Okay, so let's do fourth root of 625. So you might have to use your calculator and play around, try to find something to the fourth power. So you might have to punch in things. 3 times 3 times 3, 4 times 4 times 4, 5 times 5 times 5, 6, you can try doing that. Generally, if it ends with 25, try a number that ends with 5. Try like 5 or 15, okay, or 25. All right, so here it turns out that the answer is 5. Okay. Here, let's do the fourth root of negative 1. Okay, so again, this is an even root, and we only want to take even roots of positive numbers, or else we get imaginary. Okay, so over here, this is not real. Okay. Fifth root of negative 32. Okay, so again, you might have to play with it on your calculator. We're trying to find a number when we raise it to the fifth power. That's pretty high power. We get negative 32. Okay, so you might have to punch into your calculator 2 times 2 times 2 times 2 times 2. Okay, turns out it's going to be negative 2. Okay. So this one, the reason why we have an answer here as opposed to up here for letter B is because we can take the odd root of a negative number, but not even roots of a negative number. Okay? Odd roots are okay. Because you'll see, if you do negative 2 to the fifth power, right? Okay, so this will give us a positive result. This will give us a positive result. But then we still have this negative. So that at the very end, you'll end up with a negative. Okay? And that's what we want. Negative 2 to the fifth power is negative 32. Okay? All right, let's take a look at this one. Sixth root of 1 over 64. So, starting off with 1. Sixth root of 1 is 1. That part is easy. 64. We know it's not 8. And we know it's not 4, right? Because we know 4 to the third power is 64. Okay, but we want something to the sixth power. So if 4 is too big, try 2. And it turns out 2 times 2 times 2 times 2 times 2 times 2 to the sixth power is 64. So that is our answer. Okay? Okay, and let's try this one. So what about this? Do we need absolute value symbols here for our final answer? Yes or no? Hopefully you said no. Okay. You only need them when it's even. Okay. All right. What about this one? Fourth root, 16 x to the fourth. Okay. So fourth root of 16 is 2. And then we have x. Do we need absolute value here? Yes or no? Yes. Okay. What about this one? Sixth root, x plus 4 to the sixth. Okay. So we end up with x plus 4. Do we need absolute value? Yes. Because again, this even root. If you're taking the even root and you have variables, then you need the absolute value. Okay? And let's take a look at this last one. Fourth root, 81 x to the eighth. Okay? Fourth root of 81 is 3. Okay? But then over here, the x to the eighth, we're trying to figure out how to rewrite that raised to the fourth power. So it's going to be a 2. 2 times 4 is 8. Okay, so it's x squared here. So question, we're doing an even root. So do we need the absolute value here? Yes or no? Hopefully you said no. Okay, because remember, we use the absolute value to ensure a positive result, right? But if it's already squared, x squared is always going to be positive. So we don't need to, it's like overkill if you throw in the absolute value. Okay, because it's already going to be x squared is always going to be positive, right? Watch it. If you have -3 and you square it, that's -3 times -3. That's positive 9. Anytime you square, anytime you square a number, it's going to be positive. And that's true not just for square, but fourth power, sixth power, eighth power. Okay. All right, so that is it. If you have any questions, make sure you email me or text me.